Hello. So today we'll be looking at a topic titled light wave. What is light wave? We are all familiar with the word light. What is it about? And then why is it a wave? Okay, so we'll be considering the source of light, the properties of light, and also the applications of light today. All right. So let's move in. So the first thing here is for us to know the definition of light. Light is a visible source of energy. In other words, is what you can see with your naked eyes. You can see this light. Now it's moving. Now, for the fact that it could move, it makes it a wave. A wave is simply a disturbance. You see, it's moving. You can see that it's moving. That's why it is called a wave motion. And it has a very short wavelength. When we talk about wavelength, that's the distance that a wave can cover in one circle. Very short, and the distance is 5 times 10 to the power minus 4 millimeters. And lastly, the speed of light is 3.0 times 10 to the power 8 meter per second. So you could see that the speed of light is very high. Someone moving with the speed of light, you could see that the person has very high speed. Okay. Now, what are the sources of light? Now, light can come from two sources. It can come from natural source, and it can come from artificial source. Now, any object that can emit light by itself is what we refer to as luminous objects. So we could say that sources of light are luminous objects simply because they can emit their own light. Now we say they are divided into two. The natural source, this one emits their own light naturally on their own, such as the sunlight, the light from the sun, the light from the star, the light that we see during lightning, even some living organisms like fireflies also emit their own light by themselves, like jellyfish as well. But on the other hand, we have artificial source of light. These artificial source of light do not emit light by their own self, but rather they emit light based on the invention of man. You see the light bulb? Light bulb couldn't have emit light on its own if there is no battery. Even lamp, if there is no electricity supply, they would have emit light on their own. But there are also sources of light. It's just that they depend on man for them to come up. You see fire through being held by a hand, it wouldn't have come out on its own if a man had not done so. The same thing with torchlight and then candlelight. So these are the two categories of sources of light that we have. The next thing is what is meant by incandescent. Now, when an object is incandescent, what it means is that it emits light because it is hot. Whenever that object is hot, it emits light. An example is sun. When the sun is hot, that's when it emits its own light. So also for the stars, when the star is hot, it emits light. Lightning too comes because of what? Because of hotness. Light bulb comes up because it's hot. Lamp comes up because it's hot, and so on and so forth. So any object that brings up light or that emits light because of hotness is known as incandescent object. Okay. So another category of light source we could also say is non-incandescent light source. Just as we have said that light that emit object that emit light due to heat are not incandescent, but when they are non-incandescent, it means you don't have to heat them up before they emit their light. And a good example of them is fluorescent tube. Fluorescent tube need not be hot before it brings light. And also we have some paint that glow at night or in the dark. They need not be hot before they can glow or emit light. We have some signs like the stop sign at night. You see these signs glowing. They need not be hot before they can emit light. So they are known as non-incandescent light source. That's because they need not be heated up before they emit their light. So we also have another category of light source known as bioluminescent. Bioluminescent light sources are living things that emit light without getting hot. They just emit light on their own. For example, we have fireflies. Fireflies are an example of bioluminescent light source because it's a living organism that emits light without getting heated. Glowworms, anglerfish, viperfish, black dragonfish. These are all examples of living things that emit light on their own. Okay. Now we also have reflectors of light. What are reflectors of light? The light that cannot emit their own light. They emit light, but the light that they emit is not their own. And a good example of reflector of light is the moon. We all know the moon appears at night and it emits light. Let me let you know today that the light being emitted by the moon is not its own. What it does is that it gets its light source from the sun sends its light to the moon, and the moon emits the light on the earth. And that is why the moon is referred to as reflector of light. We have some other objects too apart from the moon. Even our mirror that we use, when light falls on mirror, we find out that it reflects the light on anyone that views it. That doesn't make the mirror a natural source of light, but rather a reflector of light. So reflectors of light cannot emit their own light, and a good example here is the moon that emits the light that we receive from the sun. Receive from the sun, and then it reflects it on the earth. The example of reflector of light, we have the moon, the mirror, the smooth waters, the metals, the smooth and shiny surface. Any shiny surfaces are all good example of reflectors of light. Okay, so we've been talking about light. Now, the rays that come from the light are also important for us to know. Now, the light emitted are represented with rays. A ray is just the direction of the path in which light is traveling. So when you trace the direction of the path of the light, that tracing is known as the ray. And we represent the ray of light with an arrow. You can see it here. On the other hand, we have what we call a beam or collection of two or more rays. Now, when you have two or more rays collected together, they are called beam of light. You see. So, collection of two or more rays of light makes a beam of light. Okay. So we need to know this so that we can get it clear when we are applying them. All right. So that's the difference between rays and beam. Now we have what we call the convergent and the divergent beam. We now know that beam is the collection of two or more rays. But now this beam can be in three different ways. It can be a parallel beam. In this case, you see that all the rays of light are moving in one direction and they are not meeting each other. You see the first arrow, the second arrow, the third arrow, fourth, fifth. They are all moving in one direction and they are not meeting each other. That is called parallel beam. On the other hand, we have what we call a divergent beam. The divergent beam, in its own case, they are coming from a particular source. At the point here, you can see, then all the rays are moving in different directions. They are not meeting. They are coming from a source and they are moving out from their source, going to different directions. That made that beam divergent beam. And the third one is called the convergent beam. In this case, it's the reverse for the divergent beam. All the rays of light are coming from different sources and they are meeting at a point. You see? So each of the rays of light in the beam are all going to meet at a point. In this case, we categorize this type of beam as converging beam. Okay. Now, that's what we call rectilinear propagation of light. It's just a phenomenon whereby light travels in a straight line. Look at this experiment here. Look at this viewer. This viewer is, looking through this 3 cardboard with holes in them. You see? And look at this candle light here. It's here to be lit up. Now, you will notice now that as soon as this candle light is lit up, the light will go through these 3 holes of cardboard A, cardboard B, and cardboard C. That's because they are on a straight line. The 3 cardboards with their holes are on a straight line. That's why the candle light can come from here and then go through, and then the viewer could see the light. You could see the light entering his eyes. But the moment that you move cardboard C away, you tilt it a little to another direction, you will see that the viewer could no longer see the light rays. That will tell you that light travels on a straight line. Because the straight line have been tampered with, the light couldn't go through the 2nd and the 3rd row. But as soon as it was adjusted again, go to the 2nd cardboard hole, and the 3rd is here to see it. So this is how to prove that light travels on a straight line, and it's known as rectilinear propagation of light. All right. Now we move to shadow. A shadow is an area in which light rays from a source cannot reach. In fact, without a light, you cannot have a shadow. What happens is a shadow is produced as a result of obstruction of light. This basketballer you're seeing here, the shadow is being seen because the light ray has been obstructed by him, and then the shadow is casted. Okay, so it's just an area that we see when the light source is obstructed. Okay, and then we need to know type of shadow that we have as a result of this. Now there are 2 major types of shadow. I want us to look at this again. Look at this video. Can you see this board and the shadow on the wall? And this bulb has a shadow. You could see the bulb shadow. You see it. Now this shadow is casted on the screen here because the bulb itself obstructs the light rays that is coming from this candle light. You can see. As a result of this obstruction, the shadow of the bulb was casted on the wall. Now, this shadow is of 2 types. We have the partial, which is called the penumbra shadow, and we have the total, which is called the umbra shadow. Now, the umbra shadow is the darkest part of the shadow, the place where the light ray could not reach at all. Okay, while the partial, the penumbra shadow, is the lighter part of the shadow. Now watch this. As this bulb is gradually moving closer to the light ray, you can see that the shadow is getting expanded. Now the lighter part of the shadow is called the penumbra, while the darker part of the shadow is known as the umbra. Okay, so that is how you distinguish between partial or penumbra shadow and the umbra shadow. The darker part is the umbra, while the lighter part is the penumbra. All right. So moving forward, we have what we call eclipse. Eclipse still occur as a result of obstruction of light. Now we need to know that eclipse and shadow are related. Now, eclipse itself simply means any obscuration of light or any obstruction of light. In this case, you could see the moon here obscuring the sun ray. Now, that obscuration or obstruction is known as eclipse. And this eclipse is of two types. Now let's see the two types of eclipse that we have. The first type of eclipse we have is known as the eclipse of the sun, also called solar eclipse. While the second one is known as the eclipse of the moon, or what we call the lunar eclipse. Now, how does the solar eclipse occur, or how does it work? Now, look at this diagram here. This object moving is the moon. You can see, by the solar system, we know that the moon moves around the earth. You see. Now, watch as it moves around. Watch it as it moves around. As it moves around. As it moves around. At the point that it gets between the sun and the earth, it casts a shadow on the earth. That point where this moon casts a shadow on the earth is what we call the eclipse of the sun. Get it now? So the eclipse of the sun occurs when the moon is between the sun and the earth, and then the moon casts its shadow on the earth. That is when we say eclipse of the sun has occurred. See, can you see now that place there, that the shadow being casted on the earth? Now on the other hand, the eclipse of the moon, which is called the lunar eclipse, this occurs also when we have the sun, the moon, and the earth. But in this case, it occurs when the earth itself has its own shadow on the moon. Now watch it. Now the sun sends its ray to the earth, and the earth now casts its shadow on the moon. Then we say this is known as the eclipse of the sun, of the moon, casting of earth's shadow on the moon. All of these is as a result of light. You see that light is a very large concept for us to know. Now, still going forward, we are going to be looking at another area we apply light, and it's what we call the pinhole camera. Today we are enjoying our digital camera, but before the invention of the digital camera, we have this locally made camera by the old scientists called the pinhole camera. Now, how does it work? It's just a simple photographic camera that creates an image using a tiny aperture. Look at this aperture here. This side is a tiny aperture. It's just a small hole. Now look at the object whose image needs to be captured. Now, this cannot happen if there is no sunlight. When the sunlight casts its ray on the object, okay, the object reflects it reflects the light rate of the sun into the pinhole camera, and the image of the object is inverted. Inverted means upside down. You can see the object, you can see the image of the object here being inverted as a result of light ray from the sun falling on the object, and the reflection of that ray going to the aperture and forming an image in inverted form. So that's how the pinhole camera works. Okay, it's as a result of what? Light availability. Right? So we need to now know what a reflection of light is. What is reflection of light? Reflection simply means the bouncing back of light. You see this torchlight, you look at the ray now going backward, this is called reflection. When the light is bouncing backward, it's called what? Reflection. When the light ray hits an object or strike an object and then it bounces backward, that process of bouncing backward is known as what? Reflection of the light. Now let's see some things, know something about this reflection of light. Now there are types of reflection. There are just two of them. The regular reflection and the diverse reflection, or sometimes called irregular reflection. Now the regular reflection of light ray occurs when the light ray incidents or fall on a smooth surface. You can see you can see the beam of light all going to the smooth surface here. Now falling on this smooth surface, it reflects as parallel ray in one direction. So the reflection of this light ray is in one direction. And that's why we call it regular reflection. When the light ray falling on a smooth object reflects in one direction. On the other hand, when you have irregular reflection, it means that when the beam of light or the light rays falling on the rough surface reflect in different directions, you could see the reflected rays in different directions, you refer that type of reflection as irregular reflection or the diverse reflection. Okay. Now we need to know the laws that guide reflection. There are just two of them. The first one, the first law of reflection, say that the incident ray is the ray that is coming from the source of light. You can see it here. The incident ray, the reflected ray, is the one that is the object and then bounce to the other direction. Okay. Now the first law states that the incident ray, the reflected ray, and the normal. The normal is a line between the incident ray and the reflected ray. You can see it here. There is the normal line. Now the incident ray, the normal ray, and the reflected ray all lies on the same plane. This is the plane here. Okay. All lies on the same plane here. Okay. That's the first law of reflection. The incident ray, the normal ray, and the reflected ray all lie on the same plane. And then the second law states that the angle of incidence is equal to the angle of reflection. And what then is the angle of incidence? The angle of incidence is the angle formed between the incident ray and the normal. Okay? The angle formed between the incident ray and the normal. If you check this here now, the angle here is known as the angle of incidence. The angle between the incident ray and the normal. While the angle of reflection is the angle between the normal and the reflected ray. So the second law states that the angle of incidence, that is theta I, you see that theta I here, which is the angle of incidence, is equals to theta R, which is the angle of reflection. So those are the two major laws of reflection. First one is that the incident ray, the normal, and the reflected ray lies on the same plane here. You can see the plane. Okay. So why the second one is the angle of incidence is equal to the angle of reflection. Right. Now moving forward to the next thing we have to do. Okay. So we haven't known the laws of reflection, so we proceed to the next one, and that is knowing the characteristics of image formed by plane mirror. Remember, we've said earlier that the plane mirror is one of the reflector of light. So we want to now know the properties of image formed by a plane mirror. Okay, this line here represents the plane mirror, while this basketballer here is the object, and then this other person here is the image of this basketballer. Now, what are the characteristics of this image here? This image that has been formed, this image here being formed by the plane mirror. This is the plane mirror here, this is the reflecting face. First of all, the first characteristic is that it is the same size with the object. In other words, if the object is 10 centimeter high, the image will be 10 centimeter high. Another characteristic is that it is virtual. When we say an image is virtual, it means that the image is not forming on the screen or is not forming on the plane surface. You could see this image here, we are not seeing it on the wall like we see shadow, so it makes it a virtual image. And another thing is that this image is laterally inverted. When something is laterally inverted, it means it is facing you. You could see that the object is facing the image. That's the lateral inversion. And then another property or characteristic is that the image is upright. It's not inverted. Remember, in the case of pinhole camera, the image form is inverted. But for mirror, the image form is upright. It's not upside down. And then another thing is that the distance between the image and the mirror is the same thing as the distance between the mirror and the object. For example, if the object from the mirror is 2 centimeter, here it will be 2 centimeter. Do we get it now? So these are the 5 characteristics of mirror, the characteristics of image form in a plane mirror. Okay. So in our next class, we are going to learn further on other applications of this light that we have been talking about. Thank you for listening.